This is problem 134, gas station. I'm going to start by reading the problem description, and then I'm going to draw out a possible solution, and then we are going to code that solution together from scratch. So let's get right into it. Gas station. The problem description says that there are n gas stations along a circular route, where the amount of gas at the ith station is gas I. You have a car with an unlimited gas tank, and it costs cost of I of gas to travel from the ith station to its next I+1th station. You begin the journey with an empty tank at one of the gas stations. Given two integer arrays gas and cost, return the starting gas station's index if you can travel around the circuit once in the clockwise direction. Otherwise, return -1. If there exists a solution, it is guaranteed to be unique. So let's just try to understand what is being asked here. We get two lists called gas and cost, two arrays of numbers of integers, gas, at each position I in gas. So for example, position 0, or the first element of gas, tells us how much gas is at that gas station. At index 1, or the second position, that tells us how much gas is at that gas station. At index 2, or the third gas station on our circular road trip, gas of 2, gas at index 2 will tell us how much gas is at that third gas station, and so on. And if we follow all of these gas stations in a circle, we end up at the same position that we started. The same is true for cost, where at each position I, we have the cost of moving from that gas station to the next gas station. And we are told that what we have to do is find out where do we begin our road trip. If we start somewhere and we can't move forward, or if we start somewhere and somewhere along our route we get stuck, that's not a valid starting position. But if we can start at some gas station with an empty gas tank, take all of the gas from that station, and then proceed to the next gas station, and repeat that until we end up completing the loop, then we know our valid starting index. We know what gas station we want to start this trip on, and if there is a solution, if there is a valid loop to make here, then it's guaranteed to be unique. There will only be one good solution, or there will be no good solutions, and no gas station can possibly get us to move in a circle around this loop without running out of gas. So, now that we've looked at this question, they actually give us a couple of examples here. So, let's take a look. Example 1. Gas is 1, 2, 3, 4, 5, and cost is 3, 4, 5, 1, 2, meaning the first gas station has 1 gallon of gas for us. The cost of moving from that first station to the next station is 3 gallons of gas. So right off the bat, just by looking at this, we can tell, well, we can't start at that position because we can only fill our empty tank with 1 gallon, but then we can't move forward because we need 3 gallons. So let's look at the second position. Can we start our loop there? Here we can get 2 gallons of gas, but the cost to move to the next station is 4. So again, this is not a valid starting position. Let's maybe try. I'm going to skip 3 3 for now because it tells us that the answer is 3, but let's look at another wrong answer. And we'll get back to 3. What if we start over here? We get 4 gallons of gas. And to get to the next station, the value at the same index is 1, meaning it costs us 1 gallon of gas to move to the next. So we get 4, we spend 1, and we move to this gas station with 3 gallons in our tank. So now that we're here, we have 3 gallons left over in our tank, and we can get another 5 gallons from this station. So we add those 5 to our existing 3 in the tank, and now we have 8. And then it costs us 2 to move in a circle to the next position. Because remember, this is a circle, so the end loops right back around to the beginning. So we have 8 gallons, and we spend 2 to go to the next gas station. And now we're here. 8 minus 2 is 6, so we have 6 gallons left. We pick up another gallon, so we have 7 gallons now. Can we spend 3? Yes. So 7 minus 3 is 4, and we can move on to the next position. We have 4 in our tank, and pick up another 2 gallons. So we have 6. Great. It's going to cost us 4 to move to the next position, which we can afford. So 6 minus 4 is 2. So when we move to this position, we have 2 gallons left in our tank. And we are so close, we need to move 1 more spot to get back to where we started and say that this was a valid starting index for a circle, for a circular route. So all we need to do is move on to the next one. Now right now, we have 2 gallons left over. Or do we? I forgot how much we have. 4 plus 1 is 5. No, 4 minus 1 is 3. Then we came here, got 8, minus 2 is 6. Got 7, minus 3 is 4. Got 2, 6 minus 4 is 2. And now we are here at the 3. And we have 3 plus the 2 in our tank, we have a 5. And the cost is a 5. So we actually can make it over here because we need 5 gallons to move, and we have 5 gallons. So we've completed our route, and it turns out that this actually is a valid starting index. I saw the 3 and the 3 over here and assumed that's what they were talking about, but the 3 is 0 based. We're talking about index 3. This is index 0. This is 1. This is 2. And this is 3. So this is actually our solution. If we were to try to start at 5, then we would have gotten stuck somewhere along the route. Let's look at that example. 5 minus 2 is 3. So when we get here, we have 3 gallons left over, plus the 1 we get here, so we have 4. Minus 3 to get to the next, so we get here with 1 gallon left over. 1 plus 2 means we have 3 gallons in our tank available, but we get stuck because we need 4 to progress. So this is not a valid starting index because we get stuck by the time we get to this position. So now that we've kind of seen how this problem works, let's see how we can solve this. Now, there is the brute force method, which can take on the order of n squared time. The brute force method is not efficient, but it makes sense logically. The way it works is to say, well, I'm going to look at this and follow this road trip all the way around, pretty much what we were just trying to do, and then see if I can make it back to here. If I can, great, I found my answer. If I can't, let's try this one. Try to make a loop. If it doesn't work, try this one. If it doesn't work, try this one. If it doesn't work, try this one. And if nothing worked, return -1, meaning there was no valid starting index. Now, this is not an efficient solution because it means that if we have n gas stations, it means that for each one of the n gas stations, we will have to do up to n work. Starting here, our road trip might take us almost all the way, but then we get stuck. And then we try this one, and again we almost do a full circle, but we get stuck. And this one we almost do a full circle, but we get stuck at the very end. And this one, in this case, it's not so true because this one we're immediately blocked, and this one we're immediately blocked because starting here, we immediately don't have enough to progress. And starting here, we immediately don't have enough to progress. And starting here, we immediately can't progress. But there can be cases where here, it kind of gives us some false hope and we go through a bunch, but then we get stuck. And here we go through a bunch and get stuck, and here and here and here, only to find out there's no valid answer, or only to find out that the only valid answer was the last one. So we want to kind of make this more efficient because, say, the list is not this length, but the list is enormous, millions of numbers, thousands or millions of numbers. All of a sudden we're here going for each one of a million numbers, doing almost a million operations. So how about we try to think of something a little bit cleaner? And for that, I'm going to whip out Microsoft Paint because we are retro. Alright, let's think about how we can possibly approach this problem. If this is the first gas station, and this is the second gas station, and this is the third gas station, and this is the fourth gas station. Now I'm not going to exactly work out to how I came to this solution, but just kind of going to talk about the solution itself and how it is that it works. This is the efficient solution, and what it asks us to do is, instead of having these two separate arrays of numbers, one called gas and one called cost, what if we actually take those and we find their difference? And that will tell us some important information. So we're going to call it net, and excuse this attempt at writing with a mouse, but we're going to define an array net such that for every index I of net, it will equal gas at I minus the cost at I. Now let's think about what this net array will mean. What the net array will mean is that if at some gas station I can get, say, 10 gallons, and the cost to move to the next station is 3 gallons, that means that passing through this gas station, that means net I will equal 7. 7 equals 10 minus 3. Let's actually write down 3 distinct cases. -3 equals 3 minus 10, and we'll go through all of these possibilities. And 0 equals 3 minus 3. These are the 3 cases for what can happen in net. We can have a positive value, we can have a negative value, or we could have a neutral value, or a 0. So if we see a positive value, what does that actually mean? It means that passing through this gas station, this particular ith gas station on our trip, will actually give us a net surplus of gas. So, if I'm running along and here I can pick up 10 gallons, but it costs me 3 to progress, well then, I could just treat this as a +7 spot. Passing through here is going to add 7 gallons to my tank, even though I'm getting some and I'm spending some. Overall, the change that will happen by passing through this gas station is going to be that I gained 7 gallons of gas. What if I see a negative value? It means that the cost was higher than the gas. It means that I got 3 gallons, for example, of gas, but I had to spend 10 to progress. So when I pass through this ith gas station, if I see a -3, it means that I'm going to be spending more than I get to pass through here, and I'm going to be losing 3 gallons out of my tank overall. That's the net change in my tank. And last but not least, if I see a 0, it just means that there's no difference to my tank passing through here because I'll get exactly the amount of gas that I need to move forward. So, I'll get 3 gallons, but I'll also use them by passing through here, and that's fine. That doesn't change my gas tank overall. So now that we kind of have this idea of the net array, we can replace our gas and cost arrays and work only on a single array, net. And this makes the problem a little bit easier, because now we're only dealing with one list, and one list that tells us all the information we need in one place, because at the end of the day that's all we care about. By passing through a gas station, what actually changes in my tank? Am I getting gas? Am I losing gas? Or is there no change? So, let's get rid of that and say that we have replaced now that we've created this net array, and say we have certain values in each position. Now we do this. We create 2 pointers, one called start and one called end. Now, because we're working on a list, by pointer all I mean is a value. I started off by saying start equals 0 and end equals 0. And this is the initial condition of our algorithm, and how it will work is every time we will try to push end forward as far as possible for this starting position. So we begin and we see a positive value, for example a 3 over here. That means with a tank that starts at 0, we gain 3 gallons, and our tank can be at 3 if we move forward from here. So that's exactly what we do, because we want to push end as far forward as possible. Now besides start and end, we also keep track of tank, and it starts at 0, and we say, well, can tank plus the value at this gas station leave us over or equal to 0? Because if it can, we have enough to keep going. And as it happens, 0 plus 3 is greater than 0. So we adjust the value of tank and push end forward, so that end is now pointing here. Now we're here, and we see a -2. Uh-oh, we're going to lose 2 gallons. But our tank is at 3, so does minus 2. Is that still greater than or equal to 0? Yes. We'll still have a whole gallon left over even if we keep moving. So we keep pushing and we adjust our 3 to a 1 because we subtracted the 2 from that gas station. But now here, we come into a problem. We have a negative 2. Surely our tank can make up for this. Well, it turns out it can't. We have 1 gallon left over in our tank, but we need to account for this net loss of 2 gallons if we want to move forward from here. And we can't do that. So, what do? What we do is we move start backwards. We say, well, there's no route that starts at this position and can go around because obviously we get stuck over here. So we need more gas for this trip. How are we going to get more gas for this trip? We say, well, what if we started earlier and our tank actually had more gas? So we move start backwards. And when we do, what do we find? Negative 3. Which doesn't help us at all. In fact, it makes things a lot worse because now that we've moved start backwards looking for more gas, we actually ended up with negative gas in the tank, which is impossible. That's not a situation we want to be in. So, what do? Well, all we can do is keep pushing start backwards and hoping we come across more gas, and enough gas not only now to cover pushing and forward, but enough gas to make up for this negative 3 that we came across along the way. And luckily, it turns out that there was 100 gas available here, and the cost of moving from this gas station to this gas station was only 3. So there's a whole 97 gallons of net gain gas at this station. It's amazing. So we say a whoop-de-doo, 97 plus negative 2 gives us 95. And that, now that we've gotten enough gas to say 95 plus this negative 2 is still greater than or equal to 0, then we move end forward one more time. And now we see that end and start are both pointing to the same gas station, meaning that we actually have a loop that circles all the way around, starting at this gas station. And that is our solution. This is an example of a case where there's a possible solution, but say, instead of 97, I came across a negative 8, which didn't help us, or even a positive 1, which helped us but didn't help enough. Then in that case, start would have moved back one more spot to here, and our tank would still be negative. So start and end would point at the same gas station, but tank would be negative, meaning this whole loop is not actually possible. And then we can return a negative 1 and say there is no possible loop because we've pushed start back as early as possible and we never made up for the gas that we needed. So hopefully this makes sense, and the reason why this is a lot more efficient than the other one is because I'm not starting at every single position and counting every single box, but instead I push end forward one time and one time and one time up until it meets up with start, and I push start back by one position and one position and one position. The two will never overlap each other, meaning at most all I do is push E forward and adjust my tank once per box and move S back once per box until they meet, so the total number of adjustments to tank can only ever equal the size of this list, the number of gas stations, meaning I only do O of N work instead of time all I did was say hop from here to here, now hop from here to here, and hop to here, and you've met. And that's all the work that I'll be doing. And that gives me the correct solution in much less repeated work. So now let's code up this idea. So what we want to do, our function is called canCompleteCircuit, and we get the gas and we get the cost. So first things first, we want to make our net array. So we say net equals an empty list for I in range length of gas, net dot append gas I minus cost I. So what am I doing here? So first we create the net array. We set it to be a blank list, and then for every index I, which will run from 0 all the way up to the length of the gas array. So if there's 10 elements, it'll go from 0 through 9. Then I append. I add to the end of this list the difference between the gas and the cost at that position, so that at the end what I have is just the differences in the exact same positions and the same order. And I've created that net array that we talked about. Now, after creating that, what do we want to do? We want to do an initial push, an initial push, an initial push, 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 push of the end pointer. So we set up the start and end pointers. Push end as far as possible. Start end equals 0, 0. What this means is I'm setting start to equal 0 and end to equal 0. And now I say while, oh, and of course we want to keep track of our tank. While tank plus net at end is greater than or equal to 0. This is the condition for our loop. It says while the gas we have in our tank already, when added with the amount of surplus or loss that we have at the current gas station where end is pointing to, as long as those two sum together, don't put our tank at the negatives, then we're good to keep moving end forward by 1. So we say end equals end plus 1, and we say tank equals tank plus net end. Now what am I doing here? I'm saying, since we know that the tank and the net difference of gas at the current station together will not put us in the negatives, we can push end forward by 1 and inspect the next gas station and see if we can further push end on the next iteration of the loop. At the same time, I want to update the value at the tank, because now the tank has been influenced by the value of whether we earned or lost gas at end. But notice I actually made a mistake here, because I've set end to be end plus 1, and then I added net end, but I added the wrong position. If you remember in the drawing, what I want to consider is the gas station that I'm pointing to before I move end forward by 1, meaning end equals end plus 1 should go after. In this way, we're talking about the same position and not accidentally talking about the next gas station. We move only after updating the tank. First, we update our tank with the gas at this station, then we point end to the next gas station. When we're done with this, then end has been pushed back as far as possible. Now, there's a special case where it happens that we've completed our loop already. So let's check for that. If end equals the length of gas, meaning if end equals the total number of gas stations, it means we've gone through every single station on this route, and our starting position is actually 0 because we've never even changed start yet. So that's a special case. Otherwise, we set start to be the length of gas minus 1. Now, why do we do this? Because start is initially, if we consider this, if we consider these as our gas stations, and initially start and end are both pointing to this first gas station, and I move end over here, and then I move end over here, and then I get stuck. Start wants to start moving backwards, so I set it over here, and then I start moving it. I start decreasing its index by 1 each time to move it backwards. So, since this list is of length 1, 2, 3, 4, 5, then this is the 0th index, the 1st, the 2nd, the 3rd, and the 4th. So, I put it at the length, which is 5 minus 1, at index 4, or the last position, and then I start pushing it back. So what I do is say tank plus equals net at start. Now notice that this time, this actually matters, because this time we actually want to add, just for clarity, this time we actually want to add the value at net after we move start, whereas here we add the value to the tank before we move end. The reason we do that is because we've already accounted for that first position, but now we move start backwards, and once we move start backwards, it's officially part of our route. End points at the potential next jump, so we push it after adding the tank, after adjusting the tank based on where we just jumped from, where we just drove through. When we move start backwards, what we're conceptually saying is, well, what if we had started at an earlier position? We've already accounted for the existing start, but what we haven't accounted for yet is the start that we just moved backwards to, the new start position. So we decrement first, and then we adjust tank. And now, we continue until start and end meet. If our tank is less than or equal to 0, if our tank is less than 0, then what does that mean? Sorry, if tank plus net end, pretty much exactly what we did up here. If our current tank plus the difference in gas that can be acquired at where end is less than at 0, that means we can't push end forward. So we move start backwards to look for gas. Start equals start minus 1, and then we want to adjust the tank. And now what about the case where we can push end forward? That means else means that tank plus net end is actually greater than or equal to 0, meaning that the current gas that we have in our tank, when adjusted by the cost of moving, or the net cost of moving forward one position, is actually going to not put us in the negatives, which is good. So in these cases, we say tank equals tank plus net end, and then end equals end plus 1. We push end forward. Now this repeats until the two meet, start and end. And when they do meet, we only have one question. Is our tank positive or 0? Or is our tank negative? Because if it's positive or 0, that means we've completed this trip in a way that's possible. But if it's negative, it means that we have run out of gas, and we never found that gas that we were looking for by pushing start backwards. So if tank is greater than or equal to 0, we return start, because that's a valid start position. Else, return -1. Let's give this code a run and see if it works. So, here's our test cases. In the case of 1, 2, 3, 4, 5, the example we ran through ourselves with 3, 4, 5, 1, 2, the output was correct. In this case, 2, 3, 4 with cost 3, 4, 3, there is no valid loop, and it shows. So let's submit this and see. And we have an error. Index out of range, while tank plus net end. Let's debug this now. We push end forward. Oh, right. While end is less than the length of gas. And so we said over here there's a special case where the loop is immediately completed, right? Where the first position is a valid start. So we push end until the end. And then we check if end equals length of gas. But what accidentally happened here is we were pushing end forward and it left the bounds of the list. And we just kept pushing it without a safety to break us out of here and get to this check. So now we've just added this while end is less than the length of gas to ensure that we never have that condition come up again. Let's try submitting this again. And let's put that. As you can see, this solution has passed. I have a couple other attempts, and we've done it. So, thanks for watching. I hope that that was entertaining or informative. Have a good night.